Hi, welcome back to College Algebra. Today we're going to look at section 4.1, inverse functions. So I have some things to say about it. I have just a little bit on the board here behind me that I'll show you in just a second. But basically, inverses undo each other. The little bit more technical definition is if you have a function f, its inverse is going to be the same function just with the ordered pairs reversed. In other words, every x and y will trade places. So you can see here I have an example of a function f. It has just three ordered pairs in it, 1, 3, 2, 7, and 5, 9. And then its inverse would be just all those same ordered pairs turned around. Now we're going to have to be just a little bit careful here because not every function is going to have an inverse. All you have to do is, just remember that with a function, every input is only allowed one output. Okay, so it's pretty easy to come up with a function where you have two different inputs that have the same output, but then when you switch them around to do the inverse, you would have two inputs then with the same output, and that'd be bad. So anyway, you just have to be a little bit careful because not every function has an inverse. All right, so what else can we say about inverses? Well, we can say these two statements. If we do a composition of functions with a function and its inverse, you will always get back what you put in. Okay, so in either direction you do that composition, that will be the case. So for instance, I'm still using these two examples back here. I have f circle f inverse of 7. Okay, and this little -1, that's not an exponent, that's just the notation that we use for an inverse. So doing the composition, I have now f with f inverse of 7. Remember, this is how a composition of functions works. And so we find f inverse of 7. Well, if we come over here to f inverse and find 7, it spits out 2. So now we have f of 2. Well, what does f of 2 spit out? If you plug in 2, you get 7 back again. So that's the idea behind this, and actually that's going to be how we show that we have inverses, except that we're going to actually do it with the rules for the function. We're going to do it with x. We're not going to do it with specific numbers, and I'll show you that on the next board. Okay, so now we want to show that f of x equal to 3x plus 5 and f inverse of x equal to x minus 5 over 3 are actually inverses. I know the notation says that they are, but we want to show that they really are. So let's take a look at how we're going to do this. What we're going to do, again, from that last board that we looked at, we're going to do a composition of functions. But now, instead of plugging numbers in, we're going to take the two rules and we're going to use those. We're going to put them together and see what happens. So first, I have to do it both ways. F circle f inverse, and then down here, f inverse circle f. So if you do the first one, f circle f inverse, that means that the inverse function is sitting inside of the f function. So f with brackets, f inverse of x on the inside. And then I take the rule for f inverse, and I'm going to put it in here into f now. So I have f of x minus 5 over 3. Well, f says take x, take whatever's inside, multiply by 3, and add 5. So you'll notice I replaced the x that's here with x minus 5 over 3, that rule that we had from the inverse, or what we're hoping is the inverse. Well, now all you have to do is just a little bit of simple algebra, simplifying, and you can see that we do end up with x. The 3's here would cancel because this is 3 times something with a 3 on the bottom, and then the minus 5 and the plus 5 would go away, leaving the x. Same thing works down here. We have to do it both ways. Okay, we did f circle f inverse, now we have to do f inverse circle f. Same process, so this means f of x is stuck on the inside, so I take its rule, which is 3x plus 5, and put it into f inverse now. And so I take that 3x plus 5, and it takes the place of this x, and that's what I have here in the parentheses. So then 5 and negative 5 get rid of each other, which leaves us with 3x over 3, and that simplifies down to x. And that's how we're going to show that we actually have inverses. Next up, and this is way more important, we're going to find inverses, because that's kind of important. So let's find inverses. All right, so now we're ready to start finding inverses. So let's get started. I have some steps. I have an example. We'll look at a couple more examples after this one too. All right, finding an inverse. First, we want to replace f of x with y. So you can see my example over here. I have f of x equal to 6x minus 4. The we're going to have to do a lot of manipulation here. It's going to be way easier if we change the f of x into y first. Okay, so that's your first step. No problem there. Second, switch x and y. This is where the inverse happens. When we take x and y and make them trade places, the same ordered pairs are going to work, but now they're going to have to be switched. They're going to have to be backwards because now x and y are in different places. So you can see here, I switched x and y. Step 3, solve for y. This is the key step. If you can get through this, you're home free. Okay, this is the only one of the 4 that's really truly difficult. Can be difficult. This one maybe isn't too bad, but some of them will be. All right, so let's solve for y. So I add 4 to both sides. I divide by 6, and now I have y by itself. That one wasn't too bad. We'll see worse. Don't worry, I've got harder examples. And then finally, replace y with f inverse of x. So now I just changed the y to f inverse of x. I switched the sides, but it doesn't really matter. Anyway, there we go. That's how you find an inverse. We'll do another example. Let's do a harder one. It'll be fun. All right, here I have a definitely more difficult example. We want to find the inverse for f of x is equal to 3x minus 4 over x, subject to x can't be 0. This is just a little tiny restriction that we have on the domain because guess what? If you plug in 0 for x, it blows up the fraction. You can't divide by 0. So that's the only purpose of this over here is to just say, whoa, 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 don't plug in 0. All right, so here's all the fun work. There's one real trick to this, and we'll see it here in just a second. So I have f of x equal to 3x minus 4 over x, and I start out just like I did before. I switch to a y instead. And then if you ignore these y's because that's something different, I swapped x and y. So I have x equals 3y minus 4 over y. Now, the reason I have these y's here is because I don't like that y in the denominator. So I multiplied both sides by y to get rid of it. Okay, on the right, the y's go away. On the left, y times x, I chose to write it as xy. So now I have xy is equal to 3y minus 4. All right, this is where it's going to start to get fun. I subtract 3y because I really want all the y's on one side. We have a very slick little trick we're going to use to make this one work. But here's the thing, don't divide anything here by y. If you do, you're just going to get back where you started, and that's a bad place to be. So I subtract the 3y because now my y's are on the same side. What that allows me to do then is to factor out a y. Y is a common factor in both of those terms, so I can pull it out and have y times x minus 3. Now we can divide by the x minus 3. When we do that, we get the y by itself. We have it's equal to negative 4 over x minus 3. And the inverse function, f inverse of x, then is negative 4 over x minus 3. And here, x would not be allowed to be positive 3 because that would blow up the domain. All right, so there we go. That's a trickier example. Definitely spend some time on that one. See if you can, get real comfortable with it. All right, I've got one more example that I want to show. So let's change the board again. Okay, so my last example is this one. F of x is equal to x minus 3 quantity squared. From what we know about graphs, this is a parabola, right? It's just got a square on it, and it's a parabola that's shifted 3 units to the right. So it comes down and hits the x-axis right at 3. Unfortunately, its inverse is not going to be a function. This fails something that we call the horizontal line test. Remember the vertical line test? Any graph, in order to represent a function, if any vertical line you pass through it hits it only once, it is a function. Well, we have a horizontal line test that kind of goes along with it. Guess what? It says any horizontal line, if it hits the graph more than once, you don't have an inverse function. So what we're going to do is we're going to do something called restricting the domain. In this case, my goal is to get all the possible y values I can out of this. So I need everything from 0 up, but I don't want any repeated y values. So basically, you can see my dotted line here on the board. I'm cutting off half of this graph. I am going to throw away that entire left-hand side. Because now I have half of a parabola. There's no repetition in the y values, which means that when I switch the x and y, it'll still be a function. So to do that, I just have to say that the domain now is x has to be greater than or equal to 3. Okay, we can't use the left-hand side. Now I can do the same process. I can find I can find the inverse, and I have. I switch to y, so we have y is equal to x minus 3 squared. Change x and y. Now I have to take a square root, add 3. Now be careful. I like to put that addition of 3 in front, because that way, sometimes if you put it after the square root, it's a little tricky to figure out. Is this the square root of x and then plus 3, or is it the square root of x plus 3 all inside there? So do yourself a favor, put the 3 in front. It's just a better way to do it. And there's our inverse. All right, so there you go. That is inverse functions. These are going to be useful because we're moving into exponential and logarithmic functions. And what we're going to see is that exponential and logarithmic functions are inverses of each other. So we're going to be able to take advantage of that as we move through the section. So thanks for coming, and I'll see you in the next video.